Everybody be quiet. Everybody be quiet.
Oh, you talking to me? Oh, I thought you was talking to him because that's typically who you talking to. I thought you was talking to him because it's typically who you asking for shit.
Do you need a pencil?
No, she does.
Do you need a pencil?
No need for that.
Alright, you guys, I'm taking points. Everybody take points. 3 days this week. I'm sending you to your dean. Be quiet. Stop talking. Collecting data. Colton, stop talking. Do you have paper? Let's do it. Let's do it. Collect your data. Write down the type of graphs. Do a little sketch. I'll show you what I mean. Right next to the word bar graph, I'm going to draw a little tiny bar graph. Just so I have a good visual. So next to the word bar graph, well, first off, go ahead and write number 1. Chapter 10 is on data analysis and displays. And so a bar graph looks like this. And I'm going to make a little note here that the bars are not touching. In a bar graph, if you draw the bars touching, that's called a histogram. You will be marked wrong. Your bars are not to be touching in a bar graph. This is called a bar graph. Correct. A histogram has the bars touching. Correct. You guys write down in your notebook what page you found this on. So during the quiz and the test, if you're using your notes, you know what page to look in your book. You're on page 878. I'm going to ask you questions on your next quiz or test about these types of displays. And you're going to say, what page is it? Page 878. Which one is that? I'll draw a circle graph. shows data organized by digit. So like let's say I had data in the 20s, the 30s, and the 40s. And let's say next to 2, I just had a 0, a 4, and a 7. Next to 3, I had 0, 0, 1, 3, 4, 7, 9. And then next to 40, I just had number 2. When data is organized in a semi-leaf plot, we can say that the majority of data is in the 30s information. Okay, so it would be a lot to write out all of these numbers, so it shortens it. This is the tens digit and this is the ones digit. So when I read this, I see 30, 30, 31, 33, 34, 37, and 39. Organizes the data so you can see where the majority of it falls. And I could say, oh, only one piece of data was higher than 40, 42. The majority of data was 39 or lower. That's a semi-leaf plot. The thing about a semi-leaf plot I was going to write down is that you must show a key. So the key would say 2 line 0 means 20, something like that. Because sometimes it'll mean like 2,000 or 3,000. Okay, box and whisker. Of all of the data up here, box and whisker is the most difficult to make. And a box and whisker shows average and the spread of the data. And then the one that I like the most maybe is the scatter plot. So I think we've already done scatter plots. So all of these 7 data displays are talked about in this chapter. And the thing about today is that, well, you've made these data displays before. You've answered questions about them. You're familiar with them. Today, you'll be tasked with the challenge of deciding which should you do based on the data. So if you were doing a survey about how many people have been to the dentist this year, which one of these would be the best way to show that data? It's numerical. Yeah, it would be like 0 times, 1 time, 2 times. Histogram would be good. When you're ready, you're going to go to page 879 and you're going to do 1 through 6 as a part of classwork today. No, I think that's the wrong page.
Yes, sir. That's the wrong.
879, 880, 1 through 6. Just a moment. And we're not talking. that would have been on page 878. Oh, I was going to show a little video of the example for you. Go ahead and do it. You guys have done this before, so go ahead and do it from your own knowledge. But I will also show a video. It's not, the video is of the example, it's not of number one.
Do we do both?
So you don't do example one, you do number one about the after school activities and the frequency.
Okay, second question.
Yeah.
There's two tables. Do we do both?
So number one is the school activities, number two is the pets,
So do
right?
we pick one?
No, we're doing 1 through 6.
So do both.
Do both of them.
You good.
The frequency table shows the number of books that 12 people read last month. Display the data in a histogram. To create the histogram, first, label the horizontal axis with the data being displayed, number of books. Label the vertical axis with frequency. Number the horizontal axis with intervals of equal size, 0 to 1, 2 to 3, 4 to 5, 6 to 7. Label the vertical axis starting at 0 to a number greater than the highest frequency. Next, create a bar for each interval with a height that corresponds to its frequency.
Just a moment. One thing that you will get graded on in this chapter is actually labeling and titling. Labeling your axis and titling. So you have after school activities down here, and then the frequency on the vertical axis. Zero to 1, 2 to 3, 4 to 5, 6 to 7. That's as high as it goes. And then the frequency you have to go all the way up to 11. So 879. So people who answered that they did 0 to 1 after school activities, there was 11 people who said that. So I'm going to go up to 11. Draw all the way down. People who said they do 2 to 3 after school activities was 8. So I'll go to 8. Go all the way down. The number that said they do 4 to 5 was 6. So I go to 6. Go all the way down. The numbers that did 6 to 7 was only 1. And this is a histogram. What's important is that the bars are actually touching. And the histogram shows how the data is spread. More people do between 0 and 1 activities than 6 or 7. 6 or 7 is too much. And then I'll title it maybe frequency of activities. Sometimes it's nice to get a highlighter and highlight inside there, make it look good. Okay, I'll jump to the percentage. One way you may have done it in pre-algebra is the number next to is over of is the percent over 100. The way they're showing it is part over whole equals percent over 100. But I can go ahead and show that video.
1% of 20 is 12. Write the percent proportion. A divided by W equals P divided by 100. A is the part. W is the whole. P is the percent divided by 100. Substitute 12 for A and 20 for W. The result is 12 divided by 20 equals P divided by 100. Simplify, the result is 60 equals P. So 60% of 20 is 12.
This is actually the situation. If you can set up the two fractions, maybe you guys have seen a teacher call it the butterfly method, where you circle these, you're actually cross multiplying. So I would do 12 times 100 equals, and then I butterfly this way, 20 times p. Did any of your teachers call it the butterfly method? Okay, that's what you're doing for 3 through 6. So that's 1200 equals 20p, and then please stop, and then divide by 20, and that's how they got to 60 equals p. They did the butterfly method. Yes. Yes, yeah. James is out. Yes, yeah. After Kennedy. Okay. So pets would be horizontal. And then for histogram, it's always frequency that goes up and down. Similar intervals, 0 to 1, 2 to 3, and 4 to 5. And now I just look, okay, the most is 5, so I just have to go 1, 2, 3, 4, 5. And then, oh, my bad. The most is 18. The most is 18. I'm actually going to go by 2s. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. So there's 10 people that had between 0 and 1 pet. 18 people had between 2 to 3 pets. And then only 2 had from 4 to 5 pets. I know some of you guys got farm animals, so you might have more than 5.
$3 and 10 chickens.
Anybody in here chickens? The impression?
You got chicken?
After
Can I
color
get one so I
stuff.
can make some maybe.
Alright, so that's our Instagram. No problem, no problem. Alright, back to is over of equals percent over 100. Okay, so what percent of 45 is 18? So I'm gonna go 18 on top, 45 on the bottom. P for percent over 100. So I'm gonna go 45 feet. I shouldn't. I went a different way. Sorry. Last time I circled this butterfly one first. 18 times 100 equals 45. Multiplying. So 1800 equals 45 feet. Divide by 45, and what's our percent? It's 40%. 18 is 40% of 45. Yeah, get your calculators out. Now, this is interesting because they've worded every single one differently to challenge you to think about it. What part of the fraction should each number go into? Okay. I don't know what you do here. Is it 200? Let's just. What percent of 56? Oh, yeah. That's exactly right. So you're thinking about money because, like, sometimes people, like, if I buy an Apple stock for $50 and then all these iPhones sell, 100% would be earning 50, but I'm gonna earn $200, so I earned over 100% of what I invested. That's it. It's more of a money thing than an object. You can't have more than 100% of an object, but your money can grow more than 100%. You know, it's like a growth. Right, right. It's not like, oh, you made 150% of your shots. Like,
But I hear I hear it used in like BMI indexes and stuff. Like fat percentages and stuff of that nature.
oh, there we go. Set these in
I
there.
want to know about that.
Okay, did you finish? Keep working. I've never tried to get a percent put on a calculator, so I'm gonna go with that. Just put a P. Just put a P there.
What?
Okay.
4 and 5?
Okay. Yeah, just use 45. Thomas, when you put the 100 under the 45, that takes care of the percent. Because if I put it on a calculator, it'd be 0.45. And then to make it a percent, you move it 2 places. All right, now this one says of what number? So they're not telling you what the of is. So right then, I'm going to use a variable x. If they don't say the number next to of, that's where you put your letter, your variable in. So I'll do my butterfly wings. 36 times 100 equals 45 times x. And who got their calculator out? Did that one? Go ahead, what is it? 4. Yeah. That's 80%. No. That's 80. Um, 36 is 45% of 80. Which makes sense because 40 would be 50% of 80.
Inverse operations be like?
What number is 80% of 120? So I'm going to put the of number in the bottom. I'm going to put the percent. The 100 is always there. And then this time we don't have an is. So next to the is where we're going to put our letter. So we start off with the x. Yeah. So our first butterfly wing is 100x. And our second butterfly wing is 80 times 120.
Verb, my boy?
Then you ask.
Callisto's going.
Oh. Tristan, what's 80 times 120?
Take 100 away. Be back right after.
And x equals 96. 96 evidently is 80% of 120. Oh, and how'd you do? Did you get number 5 right? You got 96?
Just obey.
Alright, set up the butterfly here. 1, 1, 2, 0, 0.
Your skin is red.
Equals 56.
Rose color.
Pull in. What's 11,200 divided by 56?
Rose color.
200 equals 112 is 200% of 56. Yeah, it's 56 doubled. 100% of 56 is 56. 56 doubled is 112. That tracks. Okay. Now this page was called prepare. So this is supposed to be like a little review of something you've already done. We are now gonna take some brand new notes. Well, it's not totally new, but I want you in your notebook to fold the page. So we're going to introduce some more advanced vocabulary when it comes to data display. Just fold the page over a bit so that you have or if you don't want to fold in your notebook, just draw little lines.
It's supposed to hold it. It's supposed to be, right?
Like a little 1/3 little fold, just so you can put like vocab here and definitions here. It says choosing data displays. Yeah, types of data. Alright, so this is how much information I'm going to tell you. It could be written smaller, but I'm going to fill the whole page. Why not? 1/3 would have been fine, but it's totally great. Are you ready to begin? At the top, go ahead and title it 10.1 Choosing Data Displays. Melina, are you ready? Did you title it?
I'm not ready yet.
Let's do it. Let's be ready. You be quiet over here. You want a piece of paper? Great. Very sweet. Please don't. Please don't. All right. Number 1. Types of data. Categorical. Let's take a look at that word. Category, right? You know the word category. So categorical isn't that much more difficult. Categorical. When you read the word categorical, you have to think of categories. Categories is like, I'm thinking of like Jeopardy, but you guys don't watch Jeopardy. What's something that you do in categories? Yes, they call hurricanes like they categorize hurricanes by how fast the winds are. Another way to say categorical data is to call it qualitative. So this is some more advanced vocabulary for you. All right, now I'm going to do a little description of categorical or qualitative data. No, you're the third person. Non-numerical data. Colin, stop. Colin, stop. Shh. Stop. Non-numerical data. Where the biggest thing, and this doesn't really make sense until you really get down into examples, but like doing math with categories doesn't really make sense. Like you don't add and find the averages. There's no math involved. with categorical or qualitative data. That's not the type of data you do math with. All right, the second type of data, just the opposite, numerical. And the other word for numerical is quantitative. And that's because it's talking about quantities. So the first one's talking about categories, the second one's talking about quantities, numbers. Numbers, counts, and measurements. Now, right off the bat, the first example your book uses is telephone numbers. Wow. To trick you. Okay? No. A lot of people, I hear telephone numbers and I say, what kind of data is that? And I'm thinking it's numerical because it's made of numbers, right? But do telephone numbers mean anything if you add them up? Do you find an average of a telephone number? No. Whether your telephone number has nines in it or ones in it doesn't mean anything. So telephone numbers, even though they are numbers, is actually a category or a qualitative. It's not numerical, even though it's numbers. It's not something that you add together or you measure. I wouldn't say my telephone numbers add to 500 and your telephone numbers only add to 370, so my telephone number is better than yours. No, we don't do that. We don't add telephone numbers. Please stop, Tyler. Please stop. All right, next. Univariate. A univariate only measures one characteristic. So a univariate data would be, we're collecting everyone's height today. One characteristic. We want to know your height. Now the next one is bivariate. If it's bivariate, we're collecting two pieces of data. So bivariate would be, we want to know your height and your age. Two characteristics. Hey Tristan, take your earbud out. He got you to talk to him, both of you guys. It'll be mission accomplished for him. That's it for that first types of data. Categorical, numerical, univariate, and bivariate. Fancy vocabulary for things you really already know how to do. Now we have only 3 more things to write on this paper, and it's just little tips and tricks about how to choose the type of graph. So the top half was types of data, the bottom half is how to choose the type of graph. Shoot, I need to finish. This class went by quick for me. Okay. Okay. I gotta get this done. Okay. If data is univariate and it has categories, you want to use a bar graph or circle graph. All right, so you're going to have to decide, is this measuring one characteristic or two characteristic? If it's one characteristic, then you look, okay, is this categories or numbers? If it's one characteristic and it's categories, then you do a circle graph. Or you can do a bar graph. If you do a histogram, you did it wrong. Okay, you have to pick the right representation based on the type of data. If data is univariate, but it's numerical, meaning it has to do with numbers and measurements, you're going to choose a histogram or a stem and leaf, or you can do the box and whisker, or you can do the good old dot plot. Gosh, I don't think we do a dot plot, but I know it's been a while. I don't think we do dot plots in algebra. Dot plot is when you like, oh, like you just put a dot for each one of the tallies. It's like a tally. We do tallies in algebra more than dot plots. All right, last one. If you have bivariate data, like it's not just height, it's height and age. Bivariate and it has to do with numbers. Then you're going to choose a line graph or a scatter plot. That's it. Then I want to do two with you. So I'm going to go to this assignment and do, your assignment's just to do 6. You don't have to make any graphs in your assignment today. You're trying to decide which graph to use. So, like, 884. I got 5 minutes. You can probably finish it. I don't know. I can't remember. BJ 89 under 6. So, you turn around. You don't have a butt. Four people asked to get water. 4. And 6 people went to the bathroom. And the rule for me, from my boss, 1 person at a time. And nobody the first 10 minutes, nobody the last 10 minutes. This wasn't time for 10 people to leave. Yeah. Can you imagine if we just went to water whenever anybody wanted? It'd be even more chaos.
I wouldn't be tired.
Here we go. Here we are. Page 89. You have to say, is it categories or is it numbers? Is it unit or is it by? So, brands and colors of cars in the parking lot. Okay. So, brands. Does that sound like numerical or categorical? These are categories. Now, is it talking about one category or is it talking about two categories? It's brand and color. That's two. So this is the answer. Categorical, bivariate is a category. Two different qualities of that category. Number two, the weights of the bears at the zoo. Do you think that's a number or a category? Numbers, because you can find the average. You can measure it. So we call that numerical. Is it two things or is it one thing? It's one thing. You're going all the way to 6. And then tomorrow we do more.